Thank you everyone for joining today and taking some time out of your day to come and listen to me talk about coatings testings. Just a bit of an introduction to myself. So I'm Scott Bate. I'm a section manager in our coatings and engineering's team. So our team has people who've been working in coatings and engineering for 20 plus years. We've got qualifications in terms of NACE, AMPP and ICOR, things that I'll move on to later, but sort of industry recognised qualifications there. We're sort of proud to boast as well that we do consultancy works for large contractors such as National Highways, Network Rail, things like that, sort of main contractor people. And today's really sort of introducing everyone that may not know much about coatings testing, introducing people to what coatings testing is about, where it's important to you. Often coatings are the last thing to go on a job and the first thing that we notice if they do go wrong. So just as a bit of a beginning to what we're talking about, I'm sure a lot of you out there will have had dealings with paints and coatings in the past. Some of you at home, some of you within industry, and you can understand there's such a variation in whatever we're doing that it's not as simple as open a tin, give it a quick stir and apply it to a structure, especially when we're talking about huge structures, huge bridges. To move on from that, it's a little bit of a point for us as to why that comprehensive testing matters. So a lot of us take for granted that the coating is a visual aspect, or it does actually end up being something that means that it does protect the structure, but there is a cost of coating failures that occurs throughout the industry. Worldwide, there are billions lost annually due to corrosion. So this can be anything from surface corrosion or deep pitting corrosion. That is obviously costs that the industry don't want to have to spend, money that can be spent better elsewhere. One of the key takeaways we have from that as a paint testing laboratory and paint inspectors is that we can have 60 to 90% of the coating failures traced back to inadequate preparation. So you might see paint falling off and think that's because it's bad paint. Actually, anywhere between that 60 to 90% range, depending on where your source is from, traced to the paint not going on properly in the first place, the surface not being cleaned. Again, I'll come on to this more later on. Something as well that follows quite often through construction industry is that any reworks can often cost more than the initial outlay, because at your initial outlay point, you've got a whole site to work with, you've got access, but getting back and reworking those things when you don't have that access, you don't have that site entirely to yourself, costs a lot more. And any unplanned downtime is always going to be a big impact, regardless of the industry. If you're a road or a rail, shutting that down, it's thousands of people not able to get to work, thousands of people not able to travel home to see families. I mean, we've just had the festive period. If there was shutdowns on the roads, the chaos that would cause. So what we're looking to do through coatings testing is actually prevent that. I mean, it's the same case for a lot of industries. Does what we're asking comply to the specification, and does the specification that's been written actually meet the requirements of what needs to be there? Are we looking at the risks that are provided, the risks that are offered to us, and identifying the issues within those risks before they go out to site? Are we looking at controlling those costs? Are we throwing lots and lots of money at a solution that doesn't work when we could put less money towards a solution that does work? And by that, we're going to protect the asset, and we're also going to protect any sort of stakeholder that's involved in that asset. So as Socotec's role in that, something that I do very regularly is ensuring that we've got the specialized expertise. We provide independent testing. So, we are an independent testing inspection certification leader, and we want to offer services that protect your assets and protect you as a company, a client, as whoever it is involved in that stage of coating. So a quick journey through what we're going to be covering today. There are several steps, and although I've got this in an order, from starting from number 1 at laboratory analysis and going towards 6 at failure analysis, a lot of these steps do intertwine, and you may find that you get to certain points in your coating journey when you're doing this with a structure or with any item, and you have to go from 4 back to 1 because something is missing. but we're going to be looking at laboratory analysis, pre-application testing, during application testing, post-application testing, quality control and certification, and hopefully something that not so many people have to look into is failure analysis, but we do cover that as well, because in the real world, there will always be unfortunate times where there will be failures and we need to look at that. I say I'm more than happy as we get towards the end of the presentation for people to open up questions. I'm trying to not make this as heavy as possible. I'm trying to give people a feel for what's out there, what they need to look at, and what can be done. If you've got any specific questions, I can answer them to the best of my ability. As we start at the beginning, if we were taking a new paint product from its inception, so manufacturers that are out there will be making these products. There'll be a load of whiz kids in the laboratory mixing their chemicals together and saying, we need something that fulfills X, Y, and Z criteria. Now, those manufacturers may approach us, or they may approach other clients with a product, or even clients might approach a manufacturer to produce something. Now, as with most industries, there are other requirements that must be met. There will be certain things that are banned, such as lead in paint products. There will be certain things where they're chemicals that can't be used in the UK, may be permissible in other countries. And these are all aspects of the coating that need to be considered before it even goes into a tin and goes out to site. So from my perspective, some of the key laboratory tests we're looking at are chemical composition tests. So these will be the ones that if you've got an existing paint or you've got a new paint and you want to learn what's in there, we can do resin identity analysis. It's almost like a fingerprint of that product. What that allows you to do is understand if this is an epoxy that we've already got, can we apply a suitable coating over it? Not all those coatings are intercompatible with each other. Next to that is the heavy metals testing. What we don't want to be doing is when we're painting is have the world's best paint, but putting our operatives at risk, because ultimately nothing comes above the people's welfare that you're working with. And then other things like VOC testing. So you may be familiar with on the backs of tins of paint that you might find in B&Q or somewhere like that. They have a little symbol on the back, looks like a world, and it might say low, medium, or high. There's a set classification for the analysis of VOCs. And what we're looking for is how much of that solvent is going to off-gas during that curing process or while the tin's open. Again, it's another thing to protect those operatives. We then go on to other properties, which those that have painted at home, this is where it probably falls outside of the realm of what you're used to. Those that have been doing painting on site will be a bit more familiar with. There are things like viscosity, density, and pot life. So viscosity, as simple as it is how thick the paint is. If you put it on the wall and it's really thin, it's going to run down. You're not going to be able to put that much paint on before it's all on your shoes. Density is ensuring that we've got the correct amount of solids in that. That's making sure that the paint is containing all those pigments that it should do. And pot life is more applicable to when you mix two components of a paint together. How long will those two components be suitable from going from the tin to the structure that you're applying it on before it turns into a solid mess, or before that paint doesn't do what it's supposed to anymore? Keeping going on from there is one that's always a bit of a favorite for people to come to us with is, yes, we've got this paint. Yes, we can apply it. Yes, it's good and healthy for everyone that's using it. How long will it last, and will it put up to the real world? We have the advantage of almost a weathering system that is a time machine. Unfortunately, it doesn't work as good as a time machine, but it does mean that we can cover off what is 25 years worth of exposure in 6 months in the laboratory. So you can condition something under salt spray, which simulates car spraying from a road, UV, which is useful for product which are going to be very customer facing, so where you want your color of your brand to be very clear and you don't want that to fade. And humidity is very good for instances where you are working inside a swimming pool. Yes, you don't have a lot of salts. Yes, you might not have a lot of sunlight, but the humidity will bring that paint off very quickly if it is not suitable for that environment. We then get on to the tests where we look at what incidental things may happen whilst we're on site. Your adhesion testing, chemical resistant, and impact resistance are all replicates of real world things. So if someone bashes that shipping container with a forklift truck, how well is that going to hold up to it? If someone sticks a hook to your wall and they weren't supposed to stick a hook to your wall and you ask them to pull it back off, is that going to come off with that command hook glue that's on the back of it? And chemical resistance, that's important to know. We've been told to clean this, make sure our structure looks very nice, make sure our bicycles look nice, but there's no point if you clean that and then all your paint comes off with the cleaning products. So you're looking to test various chemicals, various impact levels, various adhesion levels on those products. So you can be confident that unless someone's really going at it with malicious intent, that it should be staying as good as it was the day that paint went on. We then, from the next step, once we've confirmed all those key parts, once the paint's come to us, down the line, someone might want to say, well, this paint was tested 10 years ago. How do we know that's the same paint as when it was tested? And you can use those tests previously mentioned, and you can check the batches are consistent to the original product or consistent between products. For some industries where you've got to meet certain specifications of certain items in there, you need to be able to verify that those items are within that paint. And you always want to hold some sort of accountability and traceability to make sure, do we know that the tin of paint that was received on site on Monday is the same tin of paint that we've actually used on Friday? And there are tests that can be done on site to verify that as well. Really, for us, it's ensuring that when you ask for a product, you are getting what you want from a product, and ensuring from a manufacturer and an end user standpoint that that product is performing as it should be. And so just a sort of core purpose and key takeaway here for you is that we want to make sure that we're verifying the quality of the product early on. We don't want to find problems later on once it's already gone onto the structure. And we want, if there are going to be failures or issues, you want those to be found in a laboratory rather than found on a site. They can be easily rectified and things can be managed and changed and products can be updated and retested. It's not so easy to repaint a whole structure if you've spent 3 or 4 years doing that. The next part, which is more applicable to the real world, we start seeing the real world impact set in here, is pre-application testing. So this is when you've mobilized out to site in this case may be out on a construction site, it may be in your warehouse manufacturing facility. There are lots and lots of things that in a perfect world you can have the best paint possible, but if you're not putting it on right and you're not preparing that surface correctly, your paint is going to fail. And this is sort of coming back to that 60 to 90% of failures are due to preparation issues rather than being because of the paint product itself. So we start out with some surface cleanliness and surface profile verification. So I'll take a little bit more of a deep dive into this, going through the test. So under surface cleanliness, salt testing is a very, very big one that covers more industries than would be imagined. People think of salt, by the seaside, offshore oil rigs. Again, those are very, very stringent salt requirements out on those. But as with the weather can be in the UK, we get frozen roads, we get frozen footpaths. Gritters will be going out, gritting and salting those roads. Once water gets into that grit, tyres will be then throwing that salt up into the air and it will be depositing on anything it drives past, and it will be leaving it on the surface, and any nooks and crannies can get that salt on. So if you're working on a structure that's near, adjacent to any sort of road, salt testing is very imperative. You need to be looking at making sure the salt volume on that surface is low enough as per the manufacturer's requirement or specification requirements to make sure that you're not allowing that salt to be underneath that paint coating. Because there are 4 things that will cause corrosion and cause that paint to come off. You require an anode, a cathode, a metallic pathway, and an electrolyte. If you can get rid of one of these items, you will then reduce corrosion. The salt is part of your electrolyte. Water, the anode and cathode won't connect if there's no electrolyte connecting those together. And then subsequently, you'll have a reduced risk of corrosion. So if I've gone a bit sciencey there, I do apologize, but that's very, very key point. If that is wrong, then if it's not a clean and salt-free surface, that corrosion will be happening underneath that paint where you can't see it. And then sort of moving on and linking to that, we have the presence of corrosion. If you're painting over something and you've already got corrosion on that surface, you will be finding that that corrosion will continue to spread. You've just covered up, you've put a sticking plaster over it rather than repairing it. And then A bit further on from that, we're looking at dust and particulate assessment, things that aren't necessarily visible to the naked eye when you're painting. I know I'm guilty of it at home. If I sand down the walls, wipe it down with a wet cloth, there will still be dust on that surface that I've not seen, and I'll paint over it, and then you'll find a lot of dust or paint won't be sticking properly. The next step is how we prepare in our surface. So we've got surface profile verification. With this, if you're blasting or grinding or sanding, whatever your surface preparation may be, it needs to be clear that that is suitable for the product in question. If you're blasting, you're putting a profile in that's 30 to 75 microns. To give an idea, that's less, 30 microns is less than half the thickness of a human hair. 75 microns is roughly the thickness of a human hair. That's the range we're talking. And going below that can mean there's nothing for it to grip onto. Above that means that the surface profile is showing through the paint in its peaks and troughs. It's very important that that's good. If it won't stick, it will fall off. And that comes into the surface roughness testing as well. There are lots and lots of standards that go alongside this. It's important to remember that where you can have the best version of this possible, you should always get the best surface preparation that is available to you. Cost will always be a factor in this, but there's always going to be a cost in rework. And if you don't have to rework in the lifespan of your item, that initial larger costs that you've spent is an offset throughout the lifespan of that item. We've got a little picture there. It's not necessarily the most obvious to people. That's a close-up of a blasted steel plate. This was for a job that we carried out where the blast profile on that plate had to be between 50 and 70. So we're talking it was 200th of a millimeter that we needed to get it within. And that's how close this specification had to be. And this was for a paint product that was being used in as a tanker lining for a cargo ship. We then move on to material identification, sort of going back to some of the laboratory testing. Some people will be dealing in new build, some people will be dealing in existing systems. If you go out to a structure, we all hope there's as-built, but as I'm sure many of us know, you turn up and go, what's on there? And it was written on a scrap of paper 30 years ago, and the guy that knows what was on there is now retired. So we need to find out what's gone on, and does it contain anything nasty? And then we also need to find out what is on there. Is it suitable for applying the next system over? There's no point putting something over the top if it's just going to destroy what's underneath, and then everything's going to fall off anyway. The next biggest thing, and this will be a continuous monitoring while we're on site, is environmental monitoring. For at least 3 to 4 months of the year in the UK, if not more, it's probably poor conditions externally for most coating work. The temperature, that steel or anything you're painting outside gets so cold that dew is going to be forming on that every single day, and you can't get rid of it. The humidity in the air, if it's going to rain, we need to know about that. But also we have the other side of it. If we get 35-degree summers like we have been having, that paint can dry so fast it has its own issues where it skins over on the top and no solvent can get through that and the whole system doesn't cure properly. So continuous monitoring on that during application is important. And just a little picture of one of the gauges there. It's almost like a fire and forget gauge. You can set the parameters, you can leave it recording, you can set alarms at certain conditions, and that will alarm to tell you we are now out of spec. But it's important you monitor that, because 7 o'clock in the morning, we could be out of spec. 11 in the morning, we're back in. 1 in the afternoon, we're out of spec. 3, we're back in. There are times a day where it's going to ebb and flow for coating, and it's not just whilst you're coating, it's during the curing of that this needs to be monitored as well. And we then move on to specifiers and manufacturers' requirements. When you're selecting any coating, if you're lucky, there will be a very, very nice, stringently put together specification. If you're in charge of writing that specification, it can get slightly more difficult because you're then in charge of deciding what's going on. But if you have a specifier, or if you have a manufacturer that can aid you in that, that is always beneficial. But for our perspective, that's what we're here for. You may approach me and say, I need a product that lasts 15 years and it's going at the seaside. And I can say, okay, I know this environment, I know this classification. I can then help you build that up. I can then help you take that to site, and then I can help tell you what requirements you would need when you go out to site to monitor, because not everything that applies on one job will apply to everything else. And just a key insight going back to that 60 to 90% of coating failures are due to inadequate preparation. We want to help you prevent these failures. I would rather 100% of the time go out and stand on site, monitor what the people are doing, making sure that those conditions are good, that everything on this list here and more is good, rather than have to go back and try and determine at what point that failed. So again, some core purpose and key takeaway. So I suppose the core purpose is preventing coating failures before they become failures and preventing inadequate preparation. And we want to ensure that optimal conditions for long-term coating performance. What we don't want you doing is spending lots and lots of money on a great system, on a great application method, but finding out that actually nothing was reported, nothing was recorded when there were very preventable coating failures that we can stop. We've got the during application testing. Some of this during application testing will fall into the same vein as the pre-application testing, because it's unlike other works where you may be building a foundation, you dig a hole, you fill it with rebar and concrete, you let it cure. And if there are people out there that know more about that than me, then that's fine. There's probably a lot more that goes into it. With painting, it's a cycle, but it's a cycle where you will always constantly need to be going back to the same point. So we covered off environmental conditions. Are you painting in the correct conditions? We need to be looking at paying a lot of attention to that, a lot of focus on, will the product work in those conditions, and are we applying it and letting it cure in those correct conditions? Equipment verification. Are you using the correct tools for the job? The amount of times that the correct tools are being used, but they're not serviced, they're not calibrated. So a pressure gauge may say 40 kilopascals, and it's actually only putting 20 through. If that paint needs to go through at 40 kilopascals, then we need to up that pressure. We need to be looking at those systems. We need to be checking the grit that we're using for prepping the surface, the sandpaper that we're using. Are the guys on the correct mutes for that task, or would they be better off on scaffolding? If they need to be 30 centimeters from the surface while spraying a product, and their mutes only allowing them to be a foot away, that's a problem. It's not just the equipment the guys are actively using to apply, it's everything that helps them to apply that. And this also goes down to your health and safety aspects of it. There are products out there that require more strenuous health and safety equipment, and it's making sure that that's suitable for the paint product that's being used as well. We have wet paint quality control. So is it the right paint? There's a bit of a story here that I'm going to tell you that I covered on one of my painting courses. There was a 2-pack product, so 2 tins that you mix together makes one product, and then you apply that to the wall. They come in normally in 20 litres and 5-litre tins. There was a new chap on site, and he'd been told, we need you to mix and load the paint. So we'd been opening the tins, pouring them in. The guys had been spraying the surface. The next thing that happened was he shouted up to the guys. He goes, I've used all the big tins. Now what should I do with the little tins? So there's a bit there showing that the right paint product, although it was the right paint product, hadn't been used properly. Coming on to our next bit, hasn't been mixed properly. So all of that paint material had to be removed, had to start again completely. So it's ensuring that what you've asked for is what you've got. Has it been mixed properly? And then is it still within its pot life? So that means if you've mixed it and then gone, oh, it's lunchtime, let's everyone go for lunch. Some of those products have a pot life of 30 minutes. That paint will not be usable after that 30 minutes. It's ensuring that the second that paint is mixed, it goes on. And as soon as that pot life ends, application of that part of the paint product stops. Application assessment. Often this is carried out by whoever's applying the product, or in a factory setting. This is done hopefully by quality control. But there are more things than, is the paint going on at the right thickness and are there any unexpected snags? But you need to ensure what you've got there is a product that's going on properly. It's going on at the right thickness. It's going on at the right spreading rate. The right nozzle is there. because if it's not going on properly, again, this sort of comes back to your 60 to 90%. The paint could be brilliant, but if it's not going on correctly, it's never going to complete its job properly. Wet and dry film quality control, linking into the application assessment. The best time to look if you've got a problem is whilst you're doing the work. The next best time is just after the work's completed. If you've done 10 square meters and you check it, you only have to redo 10 square meters. If you've done 1,000 square meters or 1,000 items and then it's wrong, the likelihood is all of your 1,000 square meters is going to be wrong in some way, or all of your 1,000 items are going to be incorrect. So it's continually checking what you've got there and is it correct? And then document everything. And I know there's a lot of us that when we get told to write something down, you think, oh, another bit of paperwork. From a paint inspector view, when I go out to site, if someone's got lots and lots of documentation for me to fill in, the first thing I think is I'm cursing them for giving me so much. The next one is knowing that in 6 months' time, if an error occurs and we can go back and we can look at that specific day, I'm grateful for myself being able to fill that in. I'm grateful for whoever's implemented that system. And it's important that everything is documented, even down to what time of day, what the weather was like, was it blowing a wind across the site? Because these things are critical for knowing if something goes wrong, that's when it happened. We're not trying to place blame. We're trying to rectify it and learn a lesson and make sure that doesn't happen again. So if we were going to take some quality checkpoints out of this, we check in your environmental conditions. Are they inside or outside the specified limits? The film thickness deviations, are they within or outside of the tolerance? Is the paint too thick or too thin? If it's too thin, it doesn't do its job properly. If it's too thick, it's prone to cracking. Are there any visible application defects? Apply it the best you want. If it's missing on part of the structure, if it's running down part of the structure, again, it's an area in which that paint will fail initially. And are there any issues with equipment malfunction or any calibration problems? What we want to make sure is we're covering those off whilst we're working. And if at any point anything goes wrong or any of those go awry or outside, you stop work, because it's easier to stop work, reassess, find a new way of doing things if necessary, and carry on working. Again, our role in this is we want to provide real-time quality assurance and make sure that everyone involved gets the best end product as possible. Again, core purpose and key takeaway here. If you are continuously monitoring, if you're continuously taking information, then you get that real-time quality assurance, and it helps prevent costly rework, and you can address any deviations immediately rather than them being addressed once everyone's left site and it becomes a game of he said, she said. So following application, there will be more requirements, but a lot of what the post-application stuff relies on is what happens during application. But we will have some specified parameters, and these are only examples. You can add takeaway from this list as is project dependent. So we have physical testing, so your film thickness we should have covered, adhesion testing. We've done that in the laboratory testing. We can verify against that, make sure it's achieving the same values on site as it was in the lab. Holiday detection. So this is ensuring there are no pinholes in any tiny holes that are through that coating are ingress points for water. If water can get in, salt can get in. If salt can get in, corrosion can start. So we are detecting what are called holidays in the coating. We want to make sure that that is one uniform homogeneous coating throughout. And surface finish. We can do the best job. We can make it as corrosion resistant as possible. If you are painting a hotel, if you're painting the Ritz in London, the front of it can be protected from corrosion, but if it looks absolutely awful, no one's going to want to stop at the Ritz. They're going to want it to look nice. We've got to make sure it looks pretty. And cure assessment can happen 7 days, 3 weeks, 6 months, a year down the line. We're making sure that that paint product is curing as it should. Some products will cure instantly or within 10, 15 minutes. Some may take up to a year or even longer for full cure. And certain paints never fully cure. We're making sure that over a specified period of time, what we've got is a paint system that's dried and sealed and is a uniform shell on that building. Then documentation. Testing, recorded and logged. There's no point saying, yes, we've done it if you can't prove it. Non-conformance reports, hopefully we have none, but they are there to show that if something hasn't been done, have we logged it? Have we rectified it? Very important. Photographic evidence, a picture speaks 1,000 words. If you're trying to explain a failure down the phone to someone, send them an email. If you send that to me, it's one of those things I can look at it, and with an opinion of the experience that I've got, I can turn around and say, actually, that's blistering. There's likely you've had something trapped under that surface, or there's too much solvent in there that it narrows down what I'm trying to search for. And again, comparison against specification limits. Let's just, at the end of the job, double check. Do we have, this column says X, we've got X, excellent, tick against that. If we've got X and that says Y, we need to go back and reassess this. And we need to make sure everything meets or exceeds the project specification so we can go to final sign off. So test results pass, everything meets specs, final sign off, your project is complete. Failing that, if the test results fail below spec or outside of spec, then you're going to need more rework. That project is incomplete. You wouldn't go and get your tires changed. They do 3 out of 4 tires and that's successful. You need all 4 tires there. And it's the same with paint. We don't finish a job and leave 25% because those failures are happening as you look at the structure. The corrosion is happening as you look at it. Even if it's not visible at the moment, everything needs to go back and be checked, because what we want is to make sure we can leave that structure and come back and not have those issues in 5 years' time. So the post-application testing is making sure it meets all the specified requirements. And I suppose the takeaway is that we provide objective assurance. We're not there to say, yes, because you're my friend, I will do that. What I'm there to say is, actually, you're supposed to have achieved this. You haven't achieved that. It might sometimes make you not liked on site if you're telling people to go back and rework it, but really it's for a purpose of ensuring people are safe. If the paint's there for corrosion protection, making sure the product's good. And if you're selling something into a home, like a frying pan that has a coating on the inside, you want to make sure that someone is safe and they're not eating that coating along with whatever they're cooking. Now, just a bit on quality control and certification. So for some people, they know how to get to a certain point in this. For some people, they know how to take a coatings project from start to finish. This is for us to help you along with that step. Not everyone has done this before. And the more you dive into any subject, the more you'll find that one document references another document, which references 20 more documents. So you can get us in at project initiation. We'll help you with that specification review and planning. That means if someone said, we need to paint a bridge, but we don't know what we're doing, let us help. That's what we are there for. Material verification. So that's your laboratory testing. That's making sure whatever material we're using is suitable for the job. Application inspection, sending people out to that site, monitoring what we've discussed in the specification review. We're going on from there to documenting everything. Do you want everything written in your own format? Do you want it in our format? Are you wanting daily updates, weekly updates? Are we going to be involved in any non-conformities? Are we passing that on? These are all things that we can aid you with. We can help you learn where something does or doesn't need documenting. And then project handover. One of the things is, if you're facing someone on the other side of it and you're trying to hand something over and they're asking that technical question, we can be there to back up, give you that information, give you that advice. We're not saying we're there to argue on your behalf, but we can certainly discuss any points that have been brought up, any non-conformities and how they've been resolved and why that resolution works. And then there's ongoing support and monitoring as well. You might have an O&M manual that says every year we need 10% of the structure inspecting, and every 5 years we need 100% of the structure inspecting. It's useful for us if we were there at the inception of the paint system to go back and cover off that follow-up inspection. And then the bit that no one wants is failure investigation. This might be on the system that you've had applied. This might be on something else, but we will cover that off in a minute. So carrying on from this, we've got timeline and document review. We can go through, if you've got existing projects, we can review those timelines and the documents that you've got. Site investigations. Do you need us to go out and tell you whether something needs painting? Laboratory analysis, going back to those lab tests. we look at it and we're going, actually, yes, we can see you've got a structure. No one knows what needs to go on it. You need it repainting. We can help you formulate a cheaper or a faster alternative to what you may have been originally considering. And then we've got expert reporting and recommendations. So as part of Soccer we have an arm called Soccer Advisory. So they will deal with the legal side of things, and we operate as their site experts. So if you are facing legal ramifications or legal issues, this is where we would involve those. So they are independent, and it's where we integrate our legal advisory arm with it. So they can either be brought in by your solicitor, or if you're not at a solicitor stage, they can help advise on solicitors that can be used. They work alongside your legal advisors as well. So within your industry or within your company, you may have those already. And our aim is to work alongside you. We don't want to butt heads. We want to help you along with this. We want to look for a resolution for you effectively. We have qualified independent expert witnesses. So if this does need to go to any sort of court case, there are people out there. We can write Part 35 reports. We can aid in any sort of legal expert witnessing. We're there to take the stress off you. You point us in the direction of the job that needs reviewing, and we take that on from both an expert side in terms of the paints and coatings, and then a legal expert side, and hopefully it gets you to a dispute resolution. Or if you've got litigation that you're going to, that's what we want to aim to go for there. We do have some contact details that will be able to be shared afterwards, but the main man you want to get in touch with for that is a chap called David Smith, who's the director of Soccer Advisory. He's sort of got 40 plus years of experience in working with all sorts of legal advisory cases. And what we're doing there is working alongside him. So it might not just be coatings, it might be lots of things, but he's your man to go to. And if he doesn't know it, I'm sure there's someone that can help, then I'm not sure who will be able to. So just a little bit on this then. So we've got ensuring that basically that we help you meet all your specifications throughout the project life cycle. We don't want to just come in at the end and take all the glory. We don't want to come in at the start, leave you with something half finished and you carry on with that. We want to help you from start to finish. And it's important for us actually, because it's nice to see a job through from start to finish. Yes, okay, paints and coatings only get involved at the end, but it will be part of the specifying at the start. And then the other advantage that we offer there is if you need to back up the work that you have done, we can offer you defensible documentation. It's going to safeguard you. It's going to protect you. The more documents we give you, if you get a question saying, did you do this? Yes, we can offer that documentation. Now onto everyone's favorite part that we hope we don't have to deal with on a job we've worked on, is failure analysis. So we want to help you find the root cause of your issues. We're not here to play the blame game. We're here to make sure that structure gets the best protection it can be afforded. So we want to identify a failure exists. And I'm going to bring up a few pictures here from multiple structures. These are all jobs we've been to, need to find out why those failure exists. So just sort of top left, we've got a wheel axle. The paint's flaking off that. It's not going to be ideal for the corrosion protection. Top right was a top coat over an intumescent product. That's now no longer protecting that intumescent paint, which means there's a fire risk there. Bottom left is car park lines, which were coming up. It's okay. It's not a huge issue in terms of people can still park in that car park. But if you reduce your capacity because no one can see where to park, you're not getting as many customers in. The bottom middle is an access ramp at a ferry port that was corroding. It's a risk to passengers getting on. And the bottom right is a lighthouse. Partially that one was to do with age, but it was also, okay, why are we getting failures in certain areas of it that are corroding when we've got no metal there? So this is just sort of a small sample of the failures that we have seen, but all of these were due to incorrect preparation, all of them. So it sort of goes back to that 60 to 90% again. And it just shows the difference that proper preparation and improper preparation can make to a structure. So you've identified your failure, you approach us. We will then conduct a desktop review. Not everything will need us to go out to site, because sometimes you can actually find that information out if it was well documented in the first place, that you can see something's been applied in poor conditions. But if that is not possible or that information is not available or there aren't as built, we will do site visit and testing. The testing is ad hoc. So it will depend on your structure, it will depend on the item, it will depend on what you're looking at, or if you've got your own idea of what the failure may be, that's fine. One of the things that we always advise is that generally there'll be a main cause of failure, and then there will be subsequent smaller causes as well as that. So there may be lots and lots of little things that have led from the main thing to rectify. So there may be one overarching thing, lots of little things, and you have to rectify lots and lots of small things. And this is what can be costly. We can then continue with some laboratory analysis once we've been to site, reporting, and then should we need it, the post-report support. And that's where we're discussing with you, how do we go forwards? How do we rectify it? And if we need to bring in any sort of legal dispute help, then that's where we'll go from. The main core purpose of it is finding out why something's gone wrong. We want to find an evidence-based reason. We don't want to just go down the route of, oh, well, we think it's this because of this. We want to find evidence for it, whether that's numbers, data, information you've provided for us, and we can then provide evidence-based solutions so you can restore it and help in the future prevent it from happening again. And I suppose the takeaway from that is, if we do everything else properly, we shouldn't have failures, but it means that we can resolve failures and prevent recurrence on those as well. I've got some useful links here. These will go out when the presentation's sent out. Just some information on health and safety regarding paint products. We've got some stuff there on industrial coating failures, how to understand them and how to mitigate them. And then the bottom link is for something called FITS Atlas. Now, this is put together by a gentleman that I've worked with, and it's a very, very useful book for those that don't know a lot about what a coating failure is and how to identify different types of coating failures and understand what they are there. And there's some contact details for myself and one of my colleagues for getting in touch with us.